Okay, so the next quadrilateral we're going to be studying is our rhombus. Rhombus, by the way, is a type of parallelogram. So we've been talking about different kinds of parallelograms. So a rectangle has its own qualifications that make that a rectangle, like we talked about. And a rhombus also has its own thing. So they have the same characteristics that a parallelogram does, but not necessarily that a rectangle does. Also known as a diamond, but in mathematical terms, we use the term rhombus. The way that I made it, I can line up these sides here are congruent. So I'm going to just mark they are congruent there. So 1, 2, and 3, and 4. So that is just like our parallelogram requirement, saying that the opposite sides had to be congruent. And in this case, not only are they are congruent to the opposite side, they're actually congruent to each other. This one's a little bit harder to tell. So we're just gonna have to trust me on this one. You can kind of see here on this side that it's going along the diagonal of the squares, along as this one is along the diagonal of the squares. And had I cut this out perfectly, it would they would all be, you know, that same pattern going along this way and this way to show that they are parallel. It's a little bit harder to tell just on the paper side, but it is true that these are, just trust me on that one. All right, the next one was that opposite angles are congruent. Okay, so over here, we're going to match up our angles, and we are confirming here that the opposite angles are congruent. And on this side, if I fold it, if I fold the obtuse angles together, then, oh, look at that, they are also congruent. And I could do a couple of different ways to indicate. I don't know why I did the ticks for the first one, but I'm going to do this one for the second one. Doesn't really matter, as long as just kind of just to show a way to make them match each other. They are supplementary. So this is, if you look at it like this, it looks like kind of a squished in parallelogram. And I don't have really a good way to show that they are congruent with each other, but I guess one way, I don't know, it's kind of a crude way to do this. But let's say that this right here is the same. And if I add it over here, they make up a straight line, right? Basically to say that put those together, you are going to get yourself 180 degrees. All right, so let's talk about the diagonals, okay? So for this one, again, the diagonals for this one are actually, the way we cut it are along the lines. The diagonals that we just drew, they are going to act as angle bisectors for the opposite angles. And the diagonals, just like before, they met right there at that center spot. So that tells us that from that point, that the lines going across it are going to be the same. So this right here is congruent to this side, as well as this is congruent to this. So I'm going to indicate with some ticks here that this line is congruent to this one. This one is congruent to this one. Okay, and that can be confirmed if I fold it in half. Those lines are going to be right on top of each other, as well as this one. Okay, but they are not congruent with each other. So if I folded it along this way, they're not congruent with each other, which is going to be, I mean, they could be, but they don't have to be. We are back over at our doodle notes page. All right, so the rhombus. So a rhombus is a parallelogram with all congruent sides. So again, just kind of a quick way to say that it has the same characteristics of a parallelogram, except in this case, all the sides are congruent. Opposite angles are also congruent. Opposite sides are parallel and congruent. So meaning this one is parallel to this one. This one is parallel to this one. All right, check. And diagonals bisect each other and are congruent. And also consecutive angles are supplementary. I'm going to say that added together, they add up to 180. This angle there and this angle there together. Hopefully you guys know what I mean when I say that. That's not an official way to mark that, but there it is. Back over here at our book of quadrilaterals, we're going to scroll right on down to rhombus. Rhombi is plural, but please flip in your book of quadrilaterals to rhombi. Okay, so let's see how this rhombus relates to a parallelogram. We know that a rhombus, or any parallelogram in general, has opposite sides parallel, and that opposite sides are congruent. And while yes, opposite sides are congruent for a rhombus, they even go a little bit further to say that all four sides are actually congruent. We also know that opposite angles in a parallelogram are congruent. Consecutive angles are supplementary. And that the diagonals bisect each other. So these first 5 properties are actually the properties of a parallelogram. So rhombus falls under the umbrella of parallelogram. Now, things that are unique to the rhombus. We've already talked about how all 4 sides are congruent. We also know that diagonals are perpendicular. And diagonals bisect opposite angles. So moving right along to our first exercise. If measure of RST, this whole thing right here, is 67, they want us to find the measure of RSW. Okay, so for that one, we are going to use this property right here, that diagonals bisect opposite angles. So the measure of RSW is the measure of RST, which was 67, divided in half. Okay, all right, so you are going to use the other properties of a rhombus to help you figure out the rest of the exercises. Have fun. Okay, moving on to rhombi. This was rhombuses. I feel like that's wrong, but there it is. Okay, so again, this is a review of all the properties we've talked about again several times. They give us here a formula for the area. It looks like that's hinting to a possible problem that's going to come up later. Over here, let's do our practice problem. So here is our rhombus HIJK. So they want you to find the value of the variables, which I think you should be able to do at this point. Find the values of JK and the perimeter. Okay, so just to set it up, let's do A together. Okay, and A, I'm going to just kind of set up what I know is to be the same. Now for a rhombus, what do we know about all of the sides? That they are all congruent. So really, if you know that this is congruent with this, then you can set those equal to each other. Once you find what one is, that can help you find the other one. So in this case, r plus 1 is equal to 2r minus 4. I'm going to plug that in. I know that these guys here are equal, and that looks pretty simple. So then r plus 1 is equal to b minus 3. And instead of r, I'm going to replace that with 5 plus 1 equals b minus 3. So that means 6 equals b, and I should minus 3. That means 9 is equal to b. I know that if I find what x is, that's going to help me find j. And I do know what k is. That is going to be this guy. Okay, so those have a connection right there. I also know that added together, they are supplementary. Okay, so we now know that x is 58, which is going to be h. So that tells me the measure of angle h, which is x degrees, is equal to the measure of angle j. And so that is going to be 58 degrees. Okay, so I found this one. Yay, check. And k. Okay, so since I know what x is, I'm just going to plug it back into what I is. So this is 2. Instead of x, I'm going to write 58 plus 6. All right, so this is 122. The measure of angle K is equal to that one. And J. Okay, so go ahead and finish off C. Find the perimeter of the rhombus, as well as the other problems here with the rhombus.